hole too big, but I do want to make it oval so that that flat wire can come out. Yeah, and I know I'm using a drill, a screwdriver in place of a drill. Don't judge me. Okay. MC4 connectors, that's right, there's MC4 connectors on the solar panels. So I'm just stripping the wires. This is good old-fashioned backyard stripping. You'll notice this is landscaping wire that I'm using. It's 12 gauge. You can buy it at Home Depot. It's not too bad, but it is UV resistant. And you'll notice there's a stripe on the one side and smooth on the other. That's kind of how I know. So what I'm going to do is these little pins, and this is for the MC4 connector. Now the barrel pin, the big wide pin, you'll notice there's a narrow pin. Okay, this barrel pin over here goes into this connector. Okay, so all I'm going to do is, don't forget to do this first, is I am going to, you notice a little rubber over there, okay, is I'm going to put the striped wire on the, it's like this little male, like it's hard to tell which is male and female of this. It's the one with this little goodie over here. Twist that up, like getting it, doubling it up over there. Push that in. Get the crimp going. And if you want to, you can use a crimping tool. Crimp like that. Now this little pin pushes up into there, and you can push it up until it clicks. It's got to go all the way to the top. Okay, like that. You'll notice when you pull on it slightly, it doesn't want to come back. So I've got to remember to put these cables through the hole first before I do anything with the other side. Okay, and then do the same on the other side. Get it started. Careful, you don't want to crimp that over there because it won't fit in the hole again. All good. It squeezes up there, and you'll hear it click as well. It's quite a hard push. You need a screwdriver or something to push it up. That's not in right now. It's too wide at the back. I'm going to squash it flat a little bit. Dang, what's happening? Okay. I'm going to try and push it in with my precision tool. Right, that's in. Okay. And that's how you make an MC4 connector.
wipe all your fingerprints. Cool little hole I got there too for the wire come out. Don't be shy. Cost only $10. $10 for the XL. Clean. Don't want to accidentally put too little and have water leaking in underneath.
It looks kind of square.
I previously showed you the solar panel wires coming out the top there. This is out the back of the trailer. I'm not sure if you can see that. This is what it looks like underneath, so I'm going to zip tie these wires all the way up underneath the motorhome up to the front cabinet. I'll show you that. So I've run the cable, as you can see, along there. Now it's going into the back of this box there, and I'll show you where this goes to. Alright, so I've got my wires coming through. This is out of Motorhome. Here's the side panel. The heater in and the door, just to give you some perspective. And so you saw me downstairs there routing those wires through here, or routing them, or whatever you want to call it. And so I'm actually going to use this cavity for my battery, but I want to show you how to do a 12 volt system first, because many of you guys are going to do a 12 volt system, and then it's much easier. Just going to have some more batteries. I'm going to stick some 12 volt batteries in this little corner over here, and the inverter, I'm going to find a spot for it on the wall here somewhere, and we'll go from there. Alright, for this video I'm going to use the MPP Solar 1012LV MK. It's their latest and greatest edition. A 12 volt unit that can be parallel, so you can actually parallel up to 1000 watt, 2000 watt, and split phase everything on a 12 volt battery. So that's pretty rare. And then obviously you guys know the 1012LV MS. Sure. Dang well, I hope so. Doesn't have to be in big trouble. So I'm going to see how these mount over there. So it's a new day. I ran to the hardware store yesterday because it's recommended that you install on a non-combustible surface. So I went to go buy a piece of sheet metal that I'm going to stick on the back of this carpet over here, just to be a good citizen. Not that I'm expecting any trouble, but I'd rather have a non-combustible surface at the back than a cardboard, than a carpet wall. So I'll be installing that in a few seconds with these little tech screws over here. So there's my sheet metal installed. Now I'm going to put the inverter up. You can see I'm going to put the one screw in there. There's a place behind over here which is kind of silly, I must admit. It's a mounting hole. Well, there was one over there, but one at the bottom is good enough. And then there are two at the top that I'm going to screw in over there. So that's all mounted. Screw in there. And then because there's no hole at the top there, there's a whole lot of holes. Just use the vent holes there to screw through. There and there. Now I'm going to mount the do the wiring. And luckily the battery is right here under the stairs. So this battery's right there. So I'm just going to use the existing batteries for the first little video, and then I will be adding more batteries as we go along. So the next thing is to drill a hole through the side wall to get some cables through. This is the battery for the house, and this is the engine battery. So I'm going to be charging up the house battery, but I'm going to have a diode over there to charge the motor battery just in case. So when this one's fully charged, it'll also trickle charge the motor battery. Now, because I'm going to be adding more batteries up top here later, I'm running some welding cable. I believe this is 6 AWG, but when my batteries go up top over there in this gap, then I'll be running some thicker wire. I just want to kind of get going for the moment. 6 or 4 AWG is just fine. It's only 1,000 watts. 1,000 watts is about 80 amps, and but I'm not going to be using all of it. It's just I'll be adding later. And besides, the little battery that is inside the trailer over here would never be enough to run the whole show. Well, it would be enough for the TV and things like that, but I would like to add more, and that'll be inside. So I'll be showing you that in a short while. This is the number 6 wire I'm using. It's welding wire, like I said, and I've got 3/8 4-gauge lugs that I had, so I'm going to have to make a plan. 3/8 fit on a battery terminal just fine, and so I'm going to strip this thing double length and then double it over so it's got a nice fat connection inside that little lug hole. Use my good old trusty crimps and give that wire a little crimp there. Holes on these inverters are 5/16 holes, so that's why I'm going to use these lugs here. It's a 4-gauge input like I'm going to do. I'm going to this is a 6-gauge wire. I'm going to just double over so it fits in perfectly. Let me change if I can go a little bit, zoom out of it. And positive, as you can see, many people wonder where the screen printing is on these things. Let me see if I can zoom in a little bit. There it says positive, and there it says negative. And for the AC input, same thing, AC input, the top, the bottom, and then the PV input, positive and negative right there. Just want to give you an update. So I've got the positive and negative wire coming out from the battery, which I showed you earlier, which is under the stairs in the RV. Then I've got it into a 100 amp breaker. 100 amp at 12 volts is 1.2 kilowatts. This is a 1 kilowatt inverter, so it should be fine. About 150 amp breaker, maybe I put that in, but it's fine for now. That's going into the positive terminal on the battery side, and then you can see the negative terminal going in there. Then I've got 2 solar panels coming off the roof. They're 340 watt panels. They give out 37 volts each. And so I wired them separately like this, so that if I want to put a 48 volt system in future, you cannot charge a 48 volt battery with 37 volts. I know it's amazing, but it's not possible. So that's why I would connect these 2 wires in series in the future to have like 60 volts. And as I was saying, I had a phone call come in, so I cut the video. So positive, 2 positives wires together. You got to measure it first, obviously, with your meter. Here's my high-tech meter. I put on 50 volt scale, and I just wanted to see polarity, that's all. So I'm not sure if I need to show that to you guys, but put the positive lead over there and the negative lead, you know, over there, and then the needle swings in the right direction if the polarity is correct, and the needle goes backwards if it's the wrong polarity. So red to positive, and the needle will go the right way. Easy. And so now I'm just wiring the negative or positive wire from the PV input. I'm going to wire it to this little breaker over here, which I said is just an 80 amp breaker, 50 amp breaker, I think. Yep. And all it's doing is just if I want to just disconnect the solar from the inverter, just to push the button and disconnect. Nothing, I'm not expecting solar flares to knock a 50 amp breaker off or anything like that. It's just purely disconnect. So I'm going to go ahead, and then unfortunately I'm taking this video all by myself, so I have to pause and work. So I'm still in a bit of the stone age over here. Alright, so here we go, powering on for the first time. There's the battery. We're going to turn that on. Okay, nothing happens there. You can turn the switch on. Watch the inverter come on. Let's see. It says, let's move it to see if we get PV input. It's very hard to see. So PV input is showing there 0 volts. So now I'm going to hit the breaker over here, and let's see what happens. Uh-oh. There we go. It finally woke up. 39 volts. And let's see how many watts that is. Okay, probably at 2, 3. There we go. I was getting nervous there for a sec. So there it's pulling. We've got two 340 watt panels up there. I think they're still in the sun a little bit. The sun is now, it's what, nearly 5, 6 o'clock here in summertime here in Utah. And so we're getting about 50% of that power, and it's busy charging our battery. I'm not sure if you can see that clearly. 313 watts. Okay. Took a long time to get there, but if you can remember, so that's the angle of the sun out there at the moment, you can see, and then the panels are probably let's say about 30 degrees of sunlight on them. Another thing to note is that as the battery starts charging up fully, so the wattage from the solar panel will go down. I mean, you cannot keep charging at full wattage if the batteries are getting fully charged. So I've done nothing to this inverter. I haven't set up anything on it yet. All I did was plug it in and switch it on. It's set to AGM battery by default, and this is an AGM battery in it. So I just want to show you how easy it is without having to set a dang thing. So next thing we're going to do is the AC output, because we've got nothing hooked to the AC input and AC output, and that's what most people want to know, is how to hook that up. And I'm going to show you that in a few seconds. So what I'm going to do is, look, this is an older motorhome that has the breakers in there. It's got the 12 volt circuits, which we're not going to touch right now, because it's got the 12 volt battery that it's still running off, and this inverter is charging that. So we haven't done a thing to the 12 volt system, but we are going to run a few wires from the breaker panel down through the battery box. I'm going to run them through the side wall and up the back into the inverter. So I'll keep you tuned on that once I got this panel off. Guys, I'm just showing you a hack. You don't need to do this at all, but here's the wire going to the inverter, right? Here's the wire going to the house battery. Sorry, I figured this is the house battery. I got to think two things wrong the way around. This is the starter battery. I figured that's pretty small to start a big motor, but apparently it does. So what sometimes is, you want the solar to charge the house battery as well as charge the engine motor battery, but you don't want the motor battery to, or the house battery to run the motor battery dead. So what I did was I put a diode in place over here. So you can see there, AC. So what I did was I hooked the DC side. I mean, you can see there clearly. There's the AC side over there. So this is connected to the AC side, and then on the output is the positive. So basically what happens is, look, this battery is going to charge at like 14.7 volts. There's a 0.7 volt drop across there, or 14.3 volts. It's going to charge this battery up at 13.5 volts. So the house battery will be fully charged, but it will always trickle charge the motor battery. So that's just something that, you know, if you want to ask me more questions about it or whatever, I need to make it clearer, I can do that. But for now, if you just want to hook that wire directly to the positive terminal on your house battery, that is just fine. I just got this diode in here to kind of help and charge the house battery, I mean the car battery, but without the house battery draining the car battery. So onto the AC portion. Okay, so for the next step, what I did was turn the generator on. If this is in focus. Turn the generator on. I started it. Or you can just plug into shore power. So now I want to figure out all of the circuits that I want to run off solar. Now obviously the TV in the bedroom is one of them. So that's plugged into an outlet at the top over there, and there's an outlet over here as well. I want to just plug a light in there, and I want to go and see when I hit the breakers which circuit that belongs to, because I want the TVs on and I want the plugs on, obviously. So I'm going to open up the breaker over there. I'm not worried about the AC, like I said, in this particular and this one says receptacles, and microwave. So I know everything's on, and obviously I want the refrigerator. I don't want the refrigerator on AC because I prefer to use propane. The refrigerator has got like an electric element in it that uses 230 watts continuously, and it'll just kill the battery unless you have a huge battery. Obviously a washer and dryer, water heater definitely are big no-nos. We're just looking for this time with this little 1000 watt system. We're not worried about the AC circuit. We're not worried about the main, hopefully we'll see, but we're worried about the microwave and the receptacles. So now we're just going to go back, plug, see if our light is still working. So obviously that's not one of the circuits because I've turned the receptacles off. Maybe it's the outside receptacles. That's a good idea to have. And let's plug this light in over here and the TV. Alright, so I want to turn these breakers off until that light goes off in the bedroom. There you go. Oh, well, that just killed everything, so we don't want that. Oh, so this main one was actually the power feeding in to the main breaker because there's nothing connected to the back strips. So that's why the main turned off, so just be careful about that. Alright, so I found the circuit. It's the washer and dryer circuit, which is kind of weird. That's the circuit that runs my TV at the back. And now I'm going to figure out what these other water heater, obviously. So it might just be the microwave and these receptacles. Those are I'm gonna make solar. So I discovered these 4 circuits are the ones that I want to run off solar. Okay, those 4 over there. So I'm going to take the cover off. I'm going to turn the generator off now, and then work with those 4 wires. So in my case now, I removed the screws on the side. There's another one over there, and there, over there, and over there. Removing these so that this breaker panel can come out. Obviously make sure that everything's unplugged at this stage, right? You want no shockies. Alright, there is the thing that's called the panel. So now we're going to run a wire out the back of this, out the back here, to the inverter, actually from here to the inverter and back again. So 2 wires. I'm probably going to use 12 gauge twin and earth or Romex, we'll call it, and I will show you from there. Well, I think I found something better. Let me show you. If the camera will focus. Come on, focus. I found some 10-3 in my garage. So what I'm going to do is I'm going to run common neutral. I'm going to use the red wire for coming into the inverter, or let's say the black wire going into the inverter and the red wire coming out. So instead of me running 2 cables to the inverter and back, I've just run one. This is a 10-3 cable. So neutral is going to be in the breaker box. I'm going to make black for hot. I'm going to hook black into one of the breakers. Black's going to go into one of the breakers over there. Then the red wire is going to be from the inverter back into the loads. That's how I plan to do it, and that should be pretty simple. Alright, so I got my 10-3 coming in through there, and then into my box over there. So now I'm going to wire it up. Alright, so what I've done, pull the wire through here. I've connected the ground wire to ground, the neutral wire, the white wire over there, to the neutral bar. I am now pulling out, turn off all the breakers that I want to run off solar. Alright, so I am pulling all of those out. Let's get my leather man out here. It's hard filming and doing at the same time. So these are going to be the wires feeding the load. So my red wire I've chosen, I told you earlier, I'm going to use my red wire coming back from the inverter, my black wire going to the inverter. So I will show you in a second what I've done. So I've connected all the wires from the loads, I've removed them all from the breakers. Now I'm going to use the black wire to stick in one of the breakers that'll feed the inverter and also feed these loads. Alright, my job here is done in the breaker panel. So the black wire, got it to this 15 amp breaker. So now, just as a matter of interest, this 15 amp breaker over here is going to go into the inverter, and then it's going to feed back on this red wire to all of those 15 amp loads. So obviously now you don't have 15 amps per outlet, you've got a combined total of 15 amps. And yeah, you just got to know, obviously you cannot have a huge party and hook up all your disco speakers and what have you on the outside now. You just got to be, you know, just use a bit of caution. But 15 amps is a lot of power. So yeah, that's all you got to know. So I'm done in the breaker box. I'm going to close this up now, and then I'm going to label it so that the good lady knows what's happening. And there we go. It's getting a little bit dark now, but I want to show you an important step. Because we only have neutral, live in, the black wire, and live out, the red wire, we have to connect both neutrals together. In the AC output neutral to the AC input neutral. Otherwise you're going to get a floating neutral. And people often wonder why they're getting 58 volts on the output when they're measuring between neutral coming in and, you know, live going out. Is because the neutral isn't common. They're not common inside the machine. The only time they're common is when it's in bypass mode. But if the inverter is running, the two neutrals will not be bonded, and some people also report GFIs tripping. And so neutral wire, even if you have 6, 7, 8, 9, 10 inverters all connected in parallel, you make sure all the neutrals are bonded together. So I'm going to go ahead and do that, and then hook the wires in, and I'll show you next. Okay, so ground is common inside this inverter. So ground there is tied to ground there internally and bonded to the case. So you only need one ground wire. So AC input, remember we had that as my black wire coming in from our 15 amp breaker, coming into AC input. Neutrals are common, neutral output and neutral input are common, and then my red wire is my AC output. So now the moment of truth is, let's turn this inverter on, and I'm going to put my solar back on, even though it's getting pretty late now. Let's see basically what, when it starts up, AC input. We're not really worried about AC input because we want to know what the PIP input is. Okay, those watts should start climbing. Look, the sun is pretty low, so let's see what happens. So the MPPT will kind of figure out what is the most power it can suck off those panels. So that's why it takes a little bit of time. Excuse the light there, I'm having to use it because it's a little bit darker now. Okay, so the maximum we can suck off those two 340 watt panels on the roof right now is 57 watts. Alright, well, it's better than nothing. So let's go inside, and you can see now, if everybody wants to see, there's the, remember the solar panels came through that little 50 amp breaker. The positives tied together, negatives, I've showed you that before, and then the AC wires coming in, and the fans do run a little bit. That's the sound of them all the time. Maybe I'll be quiet. And so some guys have complained that the fans are on all the time. I do understand the fans do run, but they're not very loud, just a low little hum. And let's go inside and see if this all works. So the microwave should be on now. Okay, I'm going to close that up. Close that up. It's been a hot day today, about 100 or something degrees. So there's the microwave. It's on, running. Let's see. I'm not a microwave user. Oh, dang, you've got to read the instructions every time. I just want to get the thing going, but oh my goodness. Anyway, I'll get to that in a second. My wife's going to love that. I found a liquid bottle of soap over here to see that microwave operates, and I had to push all sorts of buttons to get this dang thing to. This is one of these touch to hold goodies. So that microwave actually tripped that inverter because those batteries were not fully charged yet. But we can make it automatically turn on again, that inverter. There we go. So it overloaded, those batteries are probably too low, and then it started up again. So the microwave runs. Let's see if we have some, where's that lead light? Going camping tomorrow and haven't got anything done yet. Okay, there's the light working. So it's all running off the inverter. Let's check out this TV over here. There we go, that works. The TV, let's plug it in up there. Alright, the light comes on, it works, it's got power. So that's a good test, right? Those batteries were at like 11 volts about 5 o'clock this afternoon, so they haven't really fully charged. So it's unfair trying to run the microwave now. So I'm going to start the generator. So the generator should be feeding into the AC input on the inverter. Just give it a little time to start, and when it starts, the AC is going to come on. Give it a second. I hate making long videos. Sorry guys, I'm just trying to condense this thing. There we go. And the AC should kick on soon. And the AC kicking on, it should supply power to the inverter AC input, and And then, if all goes well, oh my goodness, I'm going to clear again. And there you go, the microwave's busy running, cooking away. Yeah, and the spring on this bottle is getting hot, so luckily I figured that all out quickly. But yeah, this is hot over here, so not a good idea to put some metal in the microwave. Obviously, we knew that when we were kids. So, okay, so the reason I made this video in such a rush, this is at the end. And I want to go camping this weekend, and then I noticed my tire inside is flat. The double tire inside is flat. So I plugged my generator in to the little outlet over there. Turn it on. Pump the tire up from the solar panel. No generator running. Isn't that great? So away we go.